Hello class, it's Mr. Wicklehouse, and here we are again with a super wonderful, fantastic, exceptional video about right triangles and trigonometry. So today we're going to do applications of right triangle trigonometry. Now you might remember this from your geometry days where you were doing angles of elevation and depression. Here's a nice little picture. Here's Mr. Wicklehouse over here hanging out, looking at something up here. And when you're looking up, or in the picture, the description, you're looking up at something, then you're essentially talking about an angle of elevation. If you're on top of something looking down, then you're talking about an angle of depression. So it's all based upon where you're located at. If you're looking up at something, like up a hill, it's an angle of elevation. If you're at the top of a hill, or if you're in an airplane or something like that, looking down at something, then it's an angle of depression. And that angle of depression is always between a horizontal line and the line down. It's not this angle down here. It's not this one. It's this angle right here. And the angle of elevation is this angle, not this angle. So always remember that. That being said, let's do some examples. So here's a car. It's traveling up a slight grade with an angle of elevation of 2 degrees. After traveling 1 mile, what is the vertical change in feet? This particular problem, they were nice enough to find or draw you a picture, which you should always do to help you think about what's going on. But in any case, you could see the little triangle that's made, and it's always a little right triangle. We got 2 degrees right here, and then we've got the hypotenuse is 1 mile. I'm looking for this side, or the change in altitude, or the vertical change. So that's the opposite, and the hypotenuse, so I'm going to use sine. And I do sine of 2 degrees, and that's equal to x over 1. Solve this, x over 1, x ends up equaling sine of 2 degrees, so x is approximately 0.0349 miles. But maybe we want that in feet, so we're going to say x equals 0.0349 times 5280, because 5,280 feet are in a mile, and that is going to be 184.3 feet. Pretty easy after you get the picture and stuff. It's not that bad to do these. It's just simple trigonometry. Let's do another one. A man, oh, there we go. We're going to focus. We're not going to focus. Let me fix it. There we go. There we go. A man stands at the top of a 105-foot lighthouse and sees a boat. The angle of depression to sight the boat is 37 degrees. Find the distance between the base of the lighthouse and the boat. So here's my lighthouse. Whoop. Whoop, whoop, whoop. Little ball on top. There's some lines on here. Here's my man right here. Okay. Here's the land. Let's do some ocean here, and we'll put a boat on it. Here's my crappy little boat. There's the boat, and the dude is looking down here to the boat with an angle of depression. Remember, the angle of depression is always to a horizontal of 37 degrees. We know that the lighthouse is 105 feet tall. So using this triangle right here, simple sketch. That's 105. We want to know what the distance between the base of the lighthouse and the boat is. So essentially this distance, or this part of our triangle. So we've got the opposite side and the adjacent side. So then I'm going to use tangent. Tangent of 37 degrees is equal to x, which is the opposite That's not right. That's going to be 105 over x. So then we're going to switch the spots with the x and the tangent, because tangent of 37 is just a number. And we're going to get x to be equal to approximately 149.96 feet. Pretty easy. Always draw a picture if you can. One more example. Alright. From a point on the ground 12 feet from the base of a flagpole. Here's the ground. Here's the flagpole. Put a little flag on it. There's my little man. 12 feet. The angle of elevation to the top measures 53 degrees. Angle of elevation. How tall is the flagpole? Got an X there. We want to know how tall the flagpole is. Alright. Well, again, looks like we're going to use tangent because we've got the opposite and the adjacent. So we're going to do tangent of 53 equals x over 12. So then x equals 12 times the tangent of 53. So x is going to be approximately 15.92 feet. That's all there is to it, guys. I hope you have a fantastic day. See you later.